Okay, now we get to the word problems. Number 7 asks us to maximize fuel economy. The question on the exam probably won't be fuel economy, but it'll be a question like this one where a function is given and you're supposed to maximize the value or minimize the value of that function on a given interval. Excuse me. So we have the function given here. Our first step then is to take its derivative. We just use the power rule. 2 times 0.015 is 0.03. Be careful with that. I had some people in class Wednesday entering the wrong numbers into their calculator, so be careful with that. And so we have our derivative here, negative 0.03x plus 1.14, and we set that equal to 0 to find this value of x, our critical number. It's a linear function. It's very easy to solve. The one on the test is probably not a linear, but it's just as easy because it's a very simple quadratic. Actually, that's right. It's not a simple quadratic. It's but I just gave you a really strong hint on the exam as to how it would be factored. So now that we have this critical number, x equals 38, we evaluate the function. Again, the function, not the derivative. We evaluate the function at the endpoints of the interval, which in this case are 20 and 60, and we evaluate it at our critical number. And when we do, we come up with a value of 25 values of 25.1, 22.7, and 29.96. So, because 29.96 is the largest of those values, our fuel economy is greatest at 38 miles per hour. Okay, now the next question requires us to build the functions we're going to be that we're going to maximize or minimize, and this question is a cost. It's a cost question. Actually, it's a revenue question. So we're going to need our cost. And as we did back in the first week of class, we'll determine our cost using variable cost and fixed costs. Fixed costs will be identified in the question, and then all you have to do to determine the variable cost is to fill in this function, this cost function that I've got here, c of x equals mx plus b. It looks a lot like y equals mx plus b because, yeah, it's a linear function. And just realize that we're given our fixed costs, and the variable costs. To find the variable costs, just associate the word each with variable. It says here that it costs $70 to manufacture each bicycle. Well, that is the variable cost, 70. And how many of those bicycles are there? Well, that's what we're trying to find out, and that is the variable x. So our cost function is 70, the variable cost, times x, the variable, plus 100, the fixed costs identified in the problem, in the description of the problem. Well, now revenue then is going to be the quantity times the price. Well, our price function is given in the problem, so all we have to do is multiply x, the quantity, times the price function, and that's going to be our revenue function. So our profit then, which is what we're trying to maximize, is going to be revenue minus cost. The revenue function is x times the quantity, 270 minus 10x, and we'll be subtracting the cost, which is 70x plus 100, and be careful about this subtraction. Don't forget to distribute that minus across both terms. Now once you simplify all this, multiply the x through here and then subtract each of these terms, you'll come up with a function, in this case negative 2x squared plus 2x minus 100, and that's our profit function. And so since we are trying to find an absolute maximum or a minimum, in this case it's maximum because we're trying to maximize profit, we will need to take the derivative of this profit function. Once again, it's the power rule. It's very easy. And so our derivative is negative 20x plus 200. Set that equal to 0 to find the critical number. And again, a linear function, easily solved. Add 20x to both sides. Divide both sides by 20. So x equals 10. That is the number of bicycles we should produce to maximize profit. What price should we charge? Well, we have our price function right here. And so you just substitute 10 in for x to that price function. 270 minus 10 times 10. So that's 270 minus 100. That's 170, so we should charge $170. Now the profit, to find the profit at that quantity, we substitute 10 into the profit function. And when you do all this arithmetic or look at this value in your calculator, you have a profit of 900. So our quantity that maximizes profit is 10, and that profit is going to be 900. Excuse me. Now for the last question, I'm going to make a new video.